Hello everyone, my name is Shanti K. Washington. My metric number is 2210623119. So today I will explain about the fundamentals of motion control using PLC in Siemens TIA Portal. Motion control is actually crucial in industries such as manufacturing, automation, and robotics, where precision and speed are essential. Today, we will walk you through the setup, configuration, and programming of a motion control system. So let's begin with the types of motion control. Motion control is actually typically categorized into three types, where it's point-to-point control, continuous control, and position control. In this demonstration, I will focus on position control, where I will precisely control the movement of a motor to a specific position. So I created the project in TIA Portal, and I've added the PLC hardware. I've For this assignment, I've used CPU 1515-2 VN. So after creating the project and configuring the hardware, we can see that uh, we will go to the positioning axis where we have to set some basic parameters, and also there are other parameters that we have to configure, which is the hardware interface, the extended parameters, limits, foaming, and positioning monitor. Most of them are actually ready to use, but sometimes we have to check just in case. So the after after checking the positioning axis parameters and all, we can go to the we can create the logic ladder uh, in the function block. So in this program, I have used series of networks to handle different motion and control tasks. So the first network is reset. In this network, in this network will reset the motion axis to a default state. The MC reset block, which is this block, will clear any previous states or errors before starting any motion operations. The second network is the axis readiness. So this network checks if the axis is ready to start moving by verifying communication with the drive and sensor. The third network is MC power. The MC power block power up the axis, enabling motion once the system is initialized. The fourth network is MC home, where the block homes the axis, moving it to a predefined reference position. The fifth network is the MC move job. The MC move job blocks allows the job movement, enabling small incremental motion of the set of the position. Axis. The sixth network is MC velocity. The MC velocity blocks control continuous motion based on their velocity. MC relative moves the axis to a specific distance to its current position. Network 8 is the MC absolute. The MC absolute block moves the axis to an absolute position. The ninth MC halt and MC stop actually has a similar function, where the MC halt will actually stop the axis in control manner, meaning it pauses, allowing it to decelerate smoothly. Similar to MC halt, sorry, MC halt, the MC stop block actually stops the motion with more control over deceleration. The 11th, the 11th network is actual value. This network monitors real-time data such as actual speed, velocity, and position. Network 10, 12 is the standstill. In the in-range block checks if the axis has come home to complete stop by verifying its speed and velocity. The last network is the error summary, where this network summarizes any error that appeared in the system and flags any issues that if it needs attention. So that is all the 13 networks. Once the program is set up, it's time to test it. In TIA Portal, you can simulate the motion control to ensure that everything is functioning properly. The watch table, the watch table actually helps to monitor real-time data such as speed, velocity, and position, which allows us to verify that the system operates as expected. The axis control panel allows us to manually control the axis during testing. We can set the velocity, acceleration, deceleration, as well as control the direction of the motion. It displays the axis status, including whether the axis is ready to, meaning whether the axis is ready, enabled, or experiencing any error. So, for example, if I click the activate in the master control, we can see that after enabling the axis, we can see that I have clicked control for a forward motion, where we can see that the position and the velocity will change. When we click the watch table, we can see the data, where the data is actually collected for the actual speed, actual velocity, and actual position. So that's the quick overview of how I set up and tested the motion control using PLC in Siemens TIA Portal. Through the use of different function blocks and network, I am very sure that we can achieve precise and reliable control over the movement of axis. So TIA Portal actually provides an intuitive platform for designing and simulating motion control system, making it an invaluable tool for automation engineers. Thank you very much.